All right, guys. So as I was saying before I got interrupted. So I was saying that just a pie chart with these information will give you a sense of how the data is being shared and distributed. Now, using a pie chart comes with some limitations because whereas you may represent 3 sectors on this pie chart, and it might clearly give an indication of how the data is shared. But the question is, can you represent, for instance, 20 data on this chart, and so that it can give you a comfortable distinction among the sectors? What do you think, guys? Would this be sufficient to represent portions of 20 different portions? Would you be able to get a good representation from a pie chart?
Yeah.
So, go on, Mr. Ojeda. Go ahead. Mr. Ojeda. All right. Ms. Waysome. I'm not getting a response. I'm saying that would it be sufficient for
I'm sorry, okay, sir.
would it be sufficient for a pie chart to represent data of like 20 different portions? Would the pie chart be an adequate chart for representing that?
Don't think so, sir.
All right, what is the problem that you foresee using a pie chart for 20 different portions of data? If you try to construct 20 different sectors on this, you're going to really have a lot of clustering, and you're not going to really have a clear distinction among the data. You won't be able to see which data is clearly bigger than the other, and to squeeze all of those angles within it, it wouldn't be a good presentation. So for pie charts, the fewer data you have, maybe the best representation of pie chart data would be using up to about 6 or so portions might be comfortably represented with a pie chart. But anything more than that, it's going to be cumbersome or not very clear when you represent it on a pie chart. So because of that, we may use other charts, such as bar charts, when we're representing portions, many more than just probably 6 or so. All right. Now, this video, hopefully it works, is supposed to give you, it's supposed to give you kind of a video of how you would draw the pie chart. Now, I know you won't be able to hear the sound, but what I want you to do, just pay attention to what is happening. All right? And see if you can make sense of it.
Hello, we're going to do a maths test now on how to organize. So let's have another question. The question says, and the favorite colors are red, blue, green, white. That's what I'm going to do. Just going to add up how many. The reason from share that 360 degrees by up. So if we do 360 shared by 8, we will get 20. So each one of these numbers on frequency, we're going to times by the number we just want to have. So each one of these times by 20. I'll do that. I have an extra column. Angle. So 3 times 20. So the angle for it there, 60 degrees. 4 times 20 for blue. 6 times 20 for that. And 5 times 20 together. So let's just try it. So now we've worked out which angle they are, we just need to draw it on a pie chart. So to do it, I'm going to use a protractor. The circle, which is drawn white, will normally have a dot in the middle and a straight line. If it doesn't, then have to draw that straight on. So we're going to draw the first section of red, and we know we need to draw an angle. Degrees. So the way we do that, we get our protractor. We put the middle bit inside, and we turn it so that the zero on the outside of the protractor. We this section. The first section, so now we need to find the blue section. So the blue section and so we can do that, okay? So that the middle bit that section, right? Do that. 2 more to go. So now we're going to have a go at drawing the section for green. So we know for green we're going to draw it. So the method is the same. We put the protractor onto the here is my and again, I'm going to join that the center of the circle. So the last section should be 100 degrees. Well, the last section is the lowest still for it. So this last section is so we've done it. We've drawn the pie chart with all of that information. So let's retract that. Key things to remember is pie chart and sharing between having and together.
All right, guys. So let me sit down to those who would have followed and understood what was happening just now. All right, were you able to hear anything from this one, Miss Williams?
No, sir, I didn't hear anything.
Okay. Yeah, I generally have that challenge with videos, so that's the reason why I don't bother to show them on the slides. But if you are following, you should get a sense of how to measure the various sectors after you have done the calculation. So you generally start off with a straight line or a radius, vertical. Then for each angle, you would move your protractor. You line up this line with this radius and put this center right here. And then now you measure from the 0 position, you count to the angle. So if you're going to 60, you count up to 60, you put a mark on the circumference at that point. You use a ruler and you join the center to that point on the circumference. Everybody get that idea? Let me see your hands if you're all clear on that. All right, so this now is something remain for you to practice. So when you're home, and I hope if you have not yet gotten your geometry set, this would be a cue for you to get the geometry set now. So for next class, you can have your geometry set with you, and you may very well need it for some other topics when we're looking at angles. All right. All right, so with that said, we're moving on. So we would have seen how to draw a pie chart. So the next chart that we have in mind is our proportional bar chart. Now, whereas a circle, which is the pie, represents the total data, a proportional bar chart now is just a single bar that represents the total data. So clearly we're going to cut up that bar into different portions. That's like when you're slicing up bread in different portions. Then we cut up the bar in various portions and represent the data with different portions of the bar. All right. So by definition, a proportionate bar chart is a chart that displays the portion of the whole data as a fraction of a single bar. All right, so it is a chart that displays the portions, meaning the various sections of the whole data as a fraction. So each portion is represented as a fraction of the single bar. All right, now generally, when we are drawing that single bar, the height or the area of the bar can be used. But most time we are using the height, because as you know, if we are to calculate the area, we would have to find the length times width of whatever rectangular area representing the portion. But if we just use the height, then now the width of the bar would matter. If we are using the area, we'll have to now consider the width of the bar so that when you measure length times width, you get the actual area. So using the height, we're just going to draw a bar that consists of the same width throughout the entire height. All right. So the proportional bar chart relies on the height or area of each fraction to convey the proportions. The advantages of the use of this chart: it is very accurate, it is quick and easy to construct, it shows large portion of the data without confusion. Now, the pie chart would have had the same advantages too, except for when you have too much portions to represent on the pie chart, it becomes clustered. So that would have been a disadvantage. And it becomes harder to construct, less accurate, and the representation of the data wouldn't be so clear. All right. Now, in constructing the proportional bar chart, these are the steps. Step one, you draw a uniform bar with the same width throughout the length. All right, so whatever width that you start off with, you maintain it throughout the length. Second, we draw the bar on a graph paper or a plain paper. A graph paper is pretty much easier to work with because you would have already have measurement on the graph paper. But if you're going to draw it on a plain paper, you will have to use a ruler to measure the width. Now, on the graph paper, you could just choose the various centimeter boxes and count to know what width you have. All right. Now, step 3, you know the length by measuring the ruler. So the length here referring to, if you're putting it vertically, the length would be the height. If you put it horizontally, then you would have that horizontal length. All right, so know the length. So if you're drawing a bar, you must measure the length of the bar, and that length is what you're going to share up. So that length that you choose would represent the total data. And when you share that in the various fractions, each portion are going to be represented by a different length that you would also calculate it in a similar fashion as how you calculate the angles when you're dealing with the pie chart, right? So you would use the same table from the data, and then now you would write each portion of the data as a fraction of the total and times the length of the bar that you measure. All right. So using the same table, same data, and we're going to draw a proportionate bar chart. All right. So using the same data, we would have seen the data before. So we would find the total data as before. And then now we're going to write each of these as a fraction of the total and times it by the height. All right. Now here, if we are using a height of our bar being 6 centimeters, then you write each of these as a fraction of the total times 6 centimeters. So the first portion, which is 1560, as a fraction of 2,720. When you calculate that fraction by 6, which is the height of the bar, that portion of the data would get a portion of that bar to be 3.44 centimeter. All right, so the total height is a 6 centimeter bar. For this portion, which is other method, the height of that portion of the bar would be 3.44 centimeter. Do the same calculation down here. So the height of bus method of transport, we put the data for the bus over the total times 6 centimeters. So the height of this bar would be 1.85 centimeters. And here also for the private motor, we have 320 from the data. So we put that as a fraction of the total times 6, which is the height of the bar. We get a height for that portion of 0.71 centimeters. All right, so this would be our bar. And now what we would do is to do the calculation, which we would have already done. And then now, based on the calculation, we're going to measure these various heights for the various portions. So if you start off with the height of the bar being 6 centimeters, and let's say that was the first portion, when you measure the height of that, I think it was what, 3.44, correct me if I'm wrong, centimeters. So you measure that height and you put in the 3.44 for that mode of transportation. The other one, the height of it was 1 point something. So that height would measure
85.
And so
1.85.
right, so this portion would be for the bus. And of course, what would have remained would be portion of 0.71, and this portion would be for the private motor. And this is how we would represent the data on a proportional or proportionate bar chart. And as you notice, we are using just one single bar, and the width of it, we just choose a width at random, preferably one that gives you kind of a good proportion in terms of a rectangle to work with. And all you do, measure the height of it to whatever length the question specifies. So in this case, the height is 6, then you share that height by doing the calculation. And for each of the height, you draw a line to show that portion. And then now you could calculate the percentage using the same fraction, times in it by 100. All right, everybody's good with that? Let me see your hand. Now, our next chart, which is our simple bar chart, is a chart that we have a horizontal and a vertical axis. And on that horizontal axis, we would have some vertical bars. In some instances, we can have the bars on the vertical axis going horizontal. So it can be drawn two ways, either horizontal or vertical. So using the same data as above to represent by a series of bars. So a series of bars here would suggest more than one bar. So the height or length of each bar tells you the size of the data. So all we are doing now is drawing different bars, individual bars, measure their heights, and that height will give you the representation of the data. So the bar can be vertical or it can be horizontal. So in the vertical bar, you notice we would have a vertical axis that measures the amount of the data, and you draw it up to 200. Remember that other method went up to about 1560 or something like that. So based on this scale, we would count off or measure on this scale based on the data, the portion of the data that we have. So for 350, we would ensure that the height of this would line up. Let me use something more accurate. So we'll ensure that the height of this bar line up over here to 360. All right. And so that's how we determine the height based on the measurement on the y-axis. All right. And we would have done the same thing for the height of this bar. Now notice that these bars are separated from each other, but the separation doesn't matter in terms of the distance. We just want to know that the height is there. We do the separation so as to show or make a distinction that the bars are clearly different from each other. All right. Now, this is the vertical simple bar chart, but sometimes it can be horizontal too. So you would use the horizontal line and put the scale above, and then you measure that scale in the same way. Now you're using the length to measure the length of each bar. So based on this, our length would be measured in accordance to the scale above. So about right here coming down to this bar would be about 300 and what was it, 320? Right, so it has to measure 320 on this scale, and then now this length would represent that bar. And you do the same thing for the other two. This length would be what, 840? All right. And the other length would be 1560. It should be right here. So now where you're using your scale and the numbers are not clearly marked by division line, you have to just estimate the values, but based on the measurements, all right? So this is what the horizontal simple bar chart looks like, all right? Now we have this bar, which is a chronological bar chart. As the name chronological suggests, it has to do with a bar chart dealing with comparing quantities over a time period or a period of time. So that's where the chronology comes in, because chronology has to do with time going from a historical time. So like the simple bar chart, we use bars with the same width. The time is always marked off on the horizontal axis. So for this bar chart, you always put time on the horizontal axis. So if you have this table here that to put on a chronological bar chart, the years you would put on the horizontal axis, and what we are measuring up here again would be what the number of TV sold. On the this would be the frequency distribution. You put the frequency on the vertical axis. So generally, if you do the measurement of these bars, you would see that they would match the measurement in the table. And this is our chronological bar chart. All right. Now I'm going to stop here in the interest of time, because the time remaining would not allow us to do or start anything new without going through a long period. So I'm going to stop here now. All right, guys.